Alright, so here I am in a brand new Unity project, and what we're going to do to start off with is by setting up our folder structure and importing our assets. So, I'm going to create a few folders here. First of all, we need a folder for our font, so I'm going to create the font folder right there. We need another folder for materials. We need another folder for models. This is where we're going to be storing all of our 3D models. We then need a folder for our prefabs. We need a folder for our scripts. We then also need another folder here. This one is going to be for our skybox, since we are going to have a unique skybox in this game right here. We're going to create another folder as well called songs. This is where we're going to be storing our song tracks as well as our song data files, which we'll be going over later on in the course. And we need another folder here called textures. And that should be it for now. Okay, so we've got our folder set up. Now, what you can do is you can download the included zip file that comes with the course in the course files tab, and that will have multiple different assets that we'll be needing for this project. You can, of course, choose to import your own. All right, so inside of the zip file, once you extract everything, you should see 3 folders: font folder contents, models folder contents, and skybox folder contents. So I'm going to open up our font folder here, and I'm going to open up the font folder contents and drag this font in like so. And this is a font I got from Google Fonts, which is a place where you can get free fonts for your projects. All right, next up we have our models. So I'm going to open up that models folder contents, select all these models and drag them into our project like so. We have our block, which is going to basically be the object that we're going to be hitting. And then we have the 2 broken pieces, because once we hit the block, we want the block to sort of split open. And we'll have those pieces be affected by physics and fall off to the side. And then we have our sword, which is what we're going to be holding in our hands and hitting the blocks with. Okay, and finally, we have our last folder, which is the skybox folder. So, go to skybox here, drag that PNG into the scene here. Or into our project, I mean. Now, when it comes to skyboxes in Unity, these are PNG files or image files, and we need to create a material which can then render that in the form of a skybox. So what I'm going to do here is I'm going to create us a new material. I'm going to call this one skybox gradient, just like the image. I'm going to go up here to the shader, and I'm going to change this from standard over to skybox cube map. Now, cube map is basically an image that we convert into a cube. Okay, if you have a cube and you flatten it out, you have the 6 different basically faces that you can fold up into the shape of a cube. Now, our texture by default isn't like that. We need to actually convert it over to a cube map. So select the image here and go to where it says texture shape, and we're going to change that over to cube. Okay, we can then go down to the bottom here, hit apply, and now we have a cube map. We can select our material, drag that cube map in like so, and there we go. So now what we can do to actually apply it to our scene is by going up to window here, go over to rendering and click on lighting to open up the lighting window. Now in the lighting window, what we're going to do here in the scene tab is click auto generate. This is just going to basically allow Unity to auto generate the lighting, the real-time lighting for our scene, which is what we're going to be using. We then want to go over to environment here, and I'm going to drag in that skybox material over to the property here. And as you can see in our scene now, if you're looking at the scene or the game view, the skybox around us has changed this purpley blue white gradient, okay, which looks pretty cool and fits for this sort of game. You can of course create your own custom skybox. If you want, you can open up this PNG file in your favorite image editor and basically draw whatever you want on it. Okay, so next up, what we need to do is go ahead and import the XR interaction toolkit. Okay, this is basically the package that is going to give us our VR capabilities. So I'm going to go Window, Package Manager, and inside of the Package Manager here, once we fetch the packages, I'm going to go to Packages in Project here and go down to where it says Unity Registry. Okay, this will basically list all the various different packages that Unity provides us. Now, you'll see here that we don't have the XR Interaction Toolkit, and that is because by default, we have preview packages disabled. So I'm going to click on this gear icon up here, go Advanced Project Settings, And inside the project settings, we just want to go to where it says enable preview packages. Okay, I understand. And now we should be able to see the preview packages. These are basically packages that haven't been officially released yet. They're still in preview mode, but when it comes to XR Interaction Toolkit, it still works just fine. So I'm going to click on the XR Interaction Toolkit here at the bottom, go install, and that is going to begin the installation process. Once that's finished, you'll see a pop-up appearing and it will basically ask us to restart Unity. Okay, so just click yes, Unity is going to restart, and then we'll be good to go. And there we go, XR Interaction Toolkit is now installed. Now, the next step is to go ahead and also install the XR plugin management package here. This basically allows us to build and run it on our Oculus devices, or Windows MR devices if that's what you're building for. So, we're not going to download this XR plugin management directly here. Instead, what we're going to do is install a previous version, because version 3.2.17 seems to be pretty bugged for me, so I'm going to install the version beforehand. So I'm going to go see other versions, and I'm going to install 3.2.16. Okay, if the current version is a more recent version than 3.2.17, then feel free to install that and see if any errors pop up. Okay, so once that is installed, we can close out of the package manager. I'm then going to go to edit and project settings. Now in project settings, I'm going to go down to the XR plugin management tab right here, and I'm going to enable where it says plugin providers Oculus, okay, because that is the device that I'm working on. If you're using Windows MR, you can enable Windows MR right there. Now, if you are using a Steam VR or a Open VR headset, such as the Vive or the Index, unfortunately, XR Interaction Toolkit doesn't support those headsets just yet, although in the future they may. I'm also going to click on the Android icon right here and enable Oculus, since we will be building this, in my case, to an Oculus Quest 2. Okay, if you're building it to a Rift S, then you don't need to click that. Okay, so we can then exit out of the project settings window here, and our project is pretty much set up and ready to go. We've got the XR Interaction Toolkit installed, we've got all the correct plugins, we've got our assets added here. Now, in the next lesson, we are going to be setting up our scene. Okay, we'll be adding in our XR rig, we'll be setting up the environment, the platform we'll be standing on, so that we're ready to go and start creating the game. So thanks for watching, and I'll see you all in the next lesson. Welcome back everyone. In this lesson, we are going to continue on with our project by setting up our XR rig and our environment. So to begin, we need a platform for us to stand on. Okay, so what I'm going to do is I'm going to create a brand new cube object right here. So 3D object cube. I'm going to call this one our platform. And I'm going to set the position to be 0, 0, 0. Now, this is only a meter by a meter, so we might want it a bit larger. So I'm going to set the size to be 2 by 2 by 2, okay? And we want the player to be standing on the Y0 position, because generally that's the way that you want to do it. So I'm going to bring this down to be -1 on the Y, okay? So the top surface of our cube here is 0 along the Y-axis then, okay? Along with this, we also want to create a material for our platform, okay? Because a white cube is fine, but we might want it a bit darker. I'm going to go to our materials folder here and create a brand new material called platform. We can drag that onto the cube like so. I'm then going to move the smoothness down to 0. I'm going to click on where it says albedo, and I'm going to give this a texture. Now in Unity, we have this default checker texture gray that I'm going to select, and it should be applied to the cube. I'm then going to set the tiling here to be 2 by 2, just to give it a bit more of a texture. And I'm going to bring the albedo color down a bit as well, so we have a darker gray. All right, something like that. And as a matter of fact, let's change this texture over to the light one, as I think that might look a bit better. There we go. Okay, so we've got our texture applied now. What we want to do next is add some lines, and these lines are basically going to be showing the player where the notes are coming from, where the blocks are going to be coming from, okay? It's not necessary, but I think it just adds to the game. So what we're going to do in this case is we're going to right click. I'm going to create a new 3D plane right here. We can remove the mesh collider since we don't need that at all. I'm going to set this to be 0, 0, 0 here. And what we're going to do then is I'm going to change the X to be 0.0 0.005 in length, so it's a very thin line, and I'm going to set the Z to be 20. So it's a very long, very thin line. I'm going to set the X position to be 1, so it is on the right hand side here, and we can then set the Z to be, I believe, about 101 units along the Z. Okay, so it should be on the edge here. Now we might want to move it a bit in, so I'm going to set the X here to be 9 instead, or not 9, 0.9. There we go. So it is in like so. We can then select this, copy, paste, drag it over, set this to be negative 0.9 along the X. So there we go. Okay, and these lines will just basically show the player at the start of the game where the notes are coming from and give them a sort of idea on basically the plane that they're going to be coming on, and it just adds to the experience, I believe. Okay, so next what we need to do is add in our VR rig. Okay, this is going to be the player game object, which is going to have the camera, it's going to have the player's arms. Now before we do that, we need to delete the existing main camera since we won't be needing that one. And we're going to right click in the hierarchy, we're going to go down to where it says XR, device based, and we're going to choose room scale XR rig. Okay, so it's created the XR rig right here. I'm going to set that position to be 0, 0, 0, so the player is centered right here. Okay, there we go. Now, by default, this XR rig uses raycasting hands, and by that, I mean it's going to be shooting lasers out of our hands so we can point at stuff, but we don't want that, okay? We don't want our hands being able to interact with anything. So I'm going to open up our XR rig, camera offset, and I'm going to select both the left hand and the right hand controller right here. Now inside the inspector, we have our XR controller component, which is what manages the tracking, which is what manages all the inputs. So we'll keep that as it is. But down below here, we have the XR Ray interactor, the line renderer, and the XR interactor line visual. And we just want to remove those three components. So I'm going to right click on XR Ray interactor, remove component. I'm going to remove the XR line visual, remove that, and finally remove the line renderer component. So we're left with just the XR controller component attached. Okay, and that's good. So we've got our hands set up now so that they're actually not interacting with anything. And to replace that, we are going to put those swords in our player's hands. So if we go over to the models folder here, we're going to have our sword. I'm going to drag that into the left hand right here. There we go. It is now in the player's left hand. And what we're going to do is I'm just going to get onto a side profile orthographic view right here. Press F to focus in. And with our sword here, we don't want it to be pointing directly up. Okay, you can think of it as like if we have our hand and we stick up our thumb, right now the sword is going to be going in the direction of our thumb. You might want it that way, but it's going to be very awkward to hit the notes as you'll have to bend your hand basically 45 degrees down, and it's going to be quite uncomfortable. So instead what we want to do is have this sword on a bit of an angle to the right so that we don't have to bend our hand all the way down, but we don't also have to bend our hand up to not hit the notes. Okay, so I'm going to set the rotation along the X here to be 50, like so. We can then sort of move it over so that the handle is in the center of this red box, like so. As this point right here where my mouse cursor is going to be where our hand is, okay? We have our sword pretty much set up. Now what we need to do is create our materials for the sword, because in this game we're going to have basically two types of materials. We're going to have a red one and a green one. Okay, the red sword has to hit the red notes and the green sword has to hit the green notes. So in our materials folder, let's create a new material. Whoops, not a lens flare. We want to create a brand new material called color A and another material here called color B. Okay, color A, I'm going to set the smoothness to be 0 here, and I'm going to set the color to be green, like so. Then for color B, this is going to be the exact same, smoothness down to 0, and the color is going to be red. So there we go. Now, which hand do we want as what? Well, I'm going to make our right hand red and our left hand green. So since this sword is in our left hand controller, I'm going to drag on the color A material to the sword, like so. And there we go. Now, one more thing that I actually forgot to do is with this 3D model, it is very large by default. So I'm going to go to our models folder, and select the sword, and I'm going to change the scale factor here to be 0.5, basically halving the size, because in the model editor, the sword was a bit larger than it should have been. So set the scale factor to 0.5, hit apply, and the sword should resize like so. You can select it and move it back into the correct position with the center point here being on the handle. Now what we need to do with our sword is create a collider for it. Okay, this is going to allow it to actually interact with the notes. So I'm going to go add component, box collider, and on the box collider here, I'm going to set the size to be on the X 0.06, 1.4 on the Y, and 0.06 on the Z. Then for the center, we are just going to set the center on the Z to be 0 and the center on the Y to be 0.3. So you should see that this box collider is covering the blade of our sword, which is good. Okay, so we've got our sword there. Now what we also need to do is go ahead and copy this, so Control C, and paste it into the right hand. Now with the right hand, we're going to be making this a red one, so I'm going to open up our mesh renderer right here, and where it says color A, I'm going to drag in color B, basically replacing that. And you can see if we move it over to the left here, it is now red. Okay, so that's good. So there we go. We have our XR rig set up and ready to go now. If you have your headset plugged in and working, you can test it out. But in the next lesson, we are going to make a start on actually setting up our blocks that we can hit. Okay, we want to start being able to hit some blocks and have them break when we hit them. So I'll see you all then in the next lesson. Welcome back everyone. In this lesson, we are going to be setting up our blocks so we can actually hit them and destroy them. But to start off with, we are going to set up some tags for our objects, okay? So first of all, I'm going to go and select our sword here. I'm going to go to where it says tag at the top of the inspector, go add tag, and we are going to add 3 new tags. First of all, we're going to add block. This is what we're going to be tagging our blocks as. We then need a sword a sword red and a sword green. Okay, so on the left hand here we have the green material, so I'm going to tag this sword as sword green and the other sword as sword red, because once we hit a block we need to know which sword actually hit it, and a good way of determining that is by looking at the tag. Okay, did the sword red hit this block or did the sword green hit this block? And if so, are we the green block, are we the red block? Did we hit the correct note? So once we have that, what we can do now is create our main block. So I'm going to start off by creating an empty game object. I'm going to call this one block. I'm going to set the position to 000 for now. And what we're going to do is drag in a 3D model. Okay, so we're going to go to our models folder. I'm going to drag in this block model into the empty block object. Now, in this block object, you can see that we have the 3D model added like so. And for some reason, it's upside down, so I'm going to set the Z rotation to be 0, so it is facing the correct way. And we can then assign the materials. So in our materials folder here, I'm going to drag on the color A to the block here. Oops, we need to move this block out a bit actually, here. I'm going to drag on the color A material, and we also have this ring here, which is just for show, and this is just going to be a white material. So we can go ahead and create a brand new material called block ring. Okay, assign that like so, and I'm just going to make this a completely white material that has a bit of emission here. Okay, so this emission is just going to be white, and that basically makes it look like it's glowing. So we've got our block here. We need to actually rotate it around 180 degrees along the y-axis so it is facing the player. And the way this block is going to work is it's basically going to move in this direction. It's going to be moving in its forward direction towards the player. When the player hits the block, it's going to be destroyed. If they don't hit it, it's going to go past them. And once it reaches a certain point behind the player, that's when it's going to count as a missed note. Okay, so we need a couple things on this block. First of all, I'm going to tag it as block. We then need to go ahead and create ourselves a brand new script in our scripts folder. I'm going to call this C# script block. Attach that to the block object here. So select that, drag it on. We then need to attach a collider to this object. So I'm going to create a box collider like so. we need to actually bring it down in size. So I'm going to set the size to be 0.5 by 0.5 by 0.25 along the Z. So you should see now that it fits the dimensions of the block here. I'm going to enable isTrigger since we don't really want to collide with it. We sort of want our blade to pass through cleanly, and we're then going to basically destroy this block and enable some effect so that we have the broken block pieces break either side. So along with this, we also need a rigid body component, and the reason why, so I'll just add it right here, is because when you want to detect collisions or triggers between two colliders, one of those objects need to have a rigid body component, okay? At least one of them need to have a rigid body component. That is just a rule that Unity has, so what we're going to do is disable use gravity right here. We are also going to open up constraints and set all these to freeze position and freeze rotation. This basically means that we won't be able to push this object around, okay? It's basically going to be frozen in place, frozen in rotation, and whenever it says collision detection, we're going to change this from discrete over to continuous. Now, the reason why is with collision detection in Unity, you have various different methods of having that and detecting it. Discrete is the default and the most cheapest to perform. Basically, it checks to see if the collider on each frame is inside of the object, and if so, it detects a collision. Now, a problem with that is since we're going to be having our hands and we're going to be moving them very fast through the block, there could be a chance that as we move our hand quickly through a block, it actually skips past it. Okay, we have one frame above the block and the next frame is outside of the block, so there's no chance for it to actually detect that collision. And in that case, we need to change our collision detection to continuous. It's a bit more expensive, but should be fine for what we're doing. And this basically makes it so that even though on both frames there was no collider inside of the block, it can still determine, okay, our collider went from here to here, so let's see if there's anything in between those 2 points. And that's what continuous does for us. So we have our block. Now what we need to do is also set up our children objects, which are going to be the broken pieces of the block. So inside of our models folder, we have our broken block left and broken block right. We can drag those into the block like so. And these pieces here, whoops, I went to 2D mode. I'm going to disable block for now by default, just so we can actually assign some materials. So what I'm going to do is go to our materials folder, drag on the correct materials like so. And you'll see here that these two pieces are basically broken and ready to be split off. So what we can do then is attach a rigid body component to each of these, and that is going to allow us to add force to them, okay? So once we hit the block, we are going to basically get both of these objects and deparent them from the block here, okay? So they're going to be having no parent. Then we're going to destroy the original block, so only these two pieces are left. And with these two pieces, we are then going to add force to them, okay? For the block left, we're going to add force to it left, and for the right, we're going to add force to it right. So these basically fly off in either direction. And then after a couple seconds, we'll have them be destroyed, just so we don't have them continuously falling down into the void here. So I'm going to attach a rigid body component to both the block left and the block right. So add a rigid body component like so. And when it comes to the settings here, we don't really need to change anything. The default settings are just fine. So by default then, we're also going to deactivate them. So we don't want them visible by default. I'm going to re-enable our block model, and that is the block set up and ready to go. Okay, in the next lesson, we are going to be working on our block script right here so that we can actually start detecting collisions and have this block be destroyed, okay, with the nice visual going on. So I'll see you all then in the next lesson. Welcome back everyone. In this lesson, we are going to be working on our block script, okay? We'll be setting it up so that we can actually hit our block with our sword and have it be destroyed. So what we're going to do is go ahead and open up our block C# script right here inside of Visual Studio. Okay, so inside of the script here, I'm going to start off by deleting the start and update functions right here. And I am going to create some variables. Now, first of all, we need to create a variable that can keep track of what color we are as the block. So I'm going to go up here and I'm going to create an enumerator. Now, an enumerator is basically our own custom data type, which we can create and give specified values to it. Okay, so I'll show you what I mean. First of all, we're going to go public enum. Make sure this is outside of the class. It can be on top, it can be on bottom, just outside of the class. And I'm going to call this one block color. Now, inside of these squiggly brackets is where we basically give it the different possible values that this data type can be. So in our case, it can be either green or it could be red. Make sure you separate it by a comma. And back inside of our class, I'm going to create a new public block color variable here called color. All right, so there we go. Now, if we go back into the inspector now, you'll see that if we select the block, we can actually change with a drop-down menu if it's green or if it is red, and that's how an enumerator works. So down here in the rigid body component, you'll see collision detection, this is enumerator, and interpolation, this is an enumerator. So you'll see enumerators all over Unity. All right, I'm going to set this one to green here by default. Back inside of the script, what we're going to be doing is creating the rest of the variables. And this is going to be for the broken blocks, okay? The blocks that we are going to be breaking. So we need a few variables to keep track of. First of all, we need to keep track of the actual broken blocks. So we'll go public game object, broken block left. We also need a public game object for the broken block right. All right, and along with this, we need some values to determine how much force we need to apply to these objects. So I'm going to go public float, and this is going to be broken block force. So basically, once they break, how much force are we going to apply to the left or to the right of them? And along with force, we also want to apply some torque, and torque is basically rotational force, so that once they break apart, they don't look static, okay? They look like they're being spun about once we hit them. So here we're going to go public float broken block torque. And this is all going to be done using the rigid body components. And finally, we also need a public float for the broken block destroy delay. Okay, so basically, once these blocks have been forced upon and they have been broken, how many seconds until we want to destroy them? Because we don't want them to exist forever, otherwise they'll just keep falling down and taking up memory. So, how long until we destroy them? Now, what we need to do is create a function which is going to be called once this block has been hit, basically. So here we'll go void hit, creating ourselves a new function. And inside of here, we first of all want to enable the broken pieces, okay? So we'll go broken block left dot set active true. We then want to go broken block right dot set active true. Okay, so we're enabling these broken pieces, which by default are disabled. We then want to remove them as children. Okay, we no longer want these objects to be children of this object, so remove them as children. And to do that, we can go broken block left dot transform dot parent equals null. So setting this to null basically means that there's no parent, so they are basically without a parent then. So once we destroy this block, those blocks won't also be destroyed with us. We're going to do the same for right, so broken block right dot transform dot parent equals null. And next we want to add force to them, so / add force to them. And to do this, we need to get the rigid body component. So first of all, I'm going to go rigid body, and I'm going to call this left ridge equals broken block left dot get component rigid body here. We also want to create a rigid body variable for the right ridge and set that to the right one. Okay, now how do we add force to them? Well, what we're going to be doing is, first of all, for the left block, we're going to go left ridge dot add force, not add explosion force, just add force right here, and we need to give it a vector. So since we want to chuck this block towards the left-hand side, we are going to go negative transform dot right. So basically the opposite of right is left. And we want to multiply this by the broken block force. And we then want to set the force mode. Now with add force, by default, it has a force mode of force, which basically means it has a gradual increase. You can think of it as trying to push a heavy object like a car, but what we want to do is give an impulse force, which is like hitting a golf ball, okay? The moment that the bat hits the ball, that ball is moving at its fastest speed. So we want to go force mode dot impulse. And we then want to do the exact same for the right block, so add force here. This time we don't need the negative, so we're just going to go transform.right multiplied by broken block force and force mode.impulse. There we go. Now, along with adding force to them, we also want to add torque to them. And this is going to be that rotational force that we're applying. So for the left ridge, we can go dot add torque. Very similar to add force, we give it a vector of the torque that we want to add. In our case, it is going to be negative forward direction, because with the forward direction, remember we're talking about rotation. So what axis are we going to rotate around? The Z axis, as you can see here. We don't want to spin it along the X or the Y, we want to spin it along the Z. So in that case, we want to spin it around our forward vector. Now, by default, it seems like it is on negative 180. I'm going to set that to be 0, and I'm going to set the right one here to be 0 as well. Set that back to 0, 0, 0 there, and we should be good. So, back inside of our script here, when we add torque, we want to add negative forward torque, which is going to allow it to rotate left. So, transform.forward, and multiply that by the broken block torque, and set the force mode to be impulse as well. And then we can do the exact same for the right one. So add torque, and we're going to go positive transform.forward this time, multiplied by broken block torque, force mode of impulse as well. So there's a lot of stuff in this function here that we're setting up. We need to do two more things. We need to destroy each of these blocks after a couple of seconds, and then destroy the main block. So we want to destroy the broken pieces after a few seconds. So how do we do that? Well, we want to call the destroy function, which you give it a game object and it will destroy it. But something else this function has is if we give it a object such as the broken left block here, we can go comma and give it another parameter that is time. So how many seconds in the future do we want to destroy this block? And in our case, that is going to be the destroy delay, the broken block destroy delay. Okay, we can do the exact same for the right block right here. Destroy delay. And there we go. So that's going to destroy these blocks after however many seconds this variable is. And then finally, we want to destroy the main block. Okay, we want to destroy the existing block so that only these pieces remain. And to do that, we can just go destroy game object like so. Alright, so this is a pretty big function here. Now, before we actually test it out in VR, I'm going to go up here and just make it so that at start, we are going to destroy this block after a couple seconds just to see how it looks. So inside of the start function here, and this is only going to be very temporary, I'm going to go invoke hit, and let's call the hit function after maybe 3 seconds. Save that, return to the editor, and we can fill in the block variables. So on the block here, I'm going to drag in the broken block left piece, the right piece. I'm going to set the broken block force to be 8. I'm going to set the torque to be 8, and I'm going to set the destroy the delay to be 3. So if I press play and switch back over to the scene view, we should see this block here get destroyed in 3 seconds with that invoke function I called in the start function. So, and there we go. As you can see, that block just split apart and was destroyed. You can, of course, tweak all those different settings if you wish, but I think we're going to leave it at that for now. So in the next lesson, what we're going to be doing is setting it up so we can actually hit these blocks with our swords and test it out in VR. So thanks for watching, and I'll see you all in the next lesson. Welcome back, everyone. In this lesson, we are going to be setting it up so that we can finally hit our block with our sword. In the previous lesson, we set it up so that once we hit the block, it will break apart into pieces. Now let's go ahead and detect once we have actually hit the block with our sword. So, inside of the block script here, I'm going to remove the start function, which we used for testing in the previous lesson, and instead I'm going to create the void on trigger enter function. This function gets called once a collider enters another collider, if they're both triggers, which in our case ours are, and it carries over this parameter, which other is basically the other collider that collided with us. In our case, this is going to hopefully be the sword. So first things first, we need to check to see if this is a red sword or a green sword. So we can do that by going if other.compare tag let's go sword red. So basically, is this object that entered our trigger a object tagged with sword red? If that's the case, then this if statement is true. Otherwise, we'll go else if other.compare tag sword green. Now, in both cases of us hitting a block with either sword, we want to destroy that block. Okay, so we're going to call the hit function like so. But before we call the hit function, we want to see, is this the correct sword for the correct block? So, for example, if it was the red sword that hit us, are we a red block? In that case, that's correct. So we are going to add to the player's score. Otherwise, we are going to do whatever we're going to do otherwise. So we'll go if, let's just say color equals block color dot red, and that's how you can access it like so. Then we are going to add to the player score, add to the score here. Otherwise, we are going to subtract a life, or whatever sort of system that we're going to be doing in the future. We can then copy and paste this set of code, put that above the other hit function here, and instead of checking for the red block, we're going to check for the green block. So we're not going to have anything in here for now, that'll be later on in the course, but right now we can actually hit the block with our sword. So save that script, go back into Unity here, and you can then press play, make sure that your headset is plugged in correctly and working inside of Unity, press play and test it out. So there we go. I did actually have to move the block a bit closer because I couldn't reach it all the way over here. And I was only using one controller as well, that's why the other one was sort of frozen in place. But as you see, when I did hit the block, it did break apart just as we intended. So we have block breaking in place right now. So that is ready to go and set up. I think what we should do next is set up our scoring system. So once we hit a block, it'll add to our score. And if we hit the wrong block, it will reduce our life. And when our life reaches 0, that's game over. Okay. So in the next lesson, that's what we're going to do. So I'll see you all then.